Now let us solve part B using method 2, that is the method of considering perpendicular lines. So part B using method 2 says find the equation of the tangent to the circle x squared plus y squared minus 2x minus 8y plus 7 equals to 0 at the point of tangency 3 and 5. This is the point of tangency. That is the point on the circumference of the circle where the tangent touches the curve, touches the circle rather. So from here, if we are using the method of perpendicular lines, it means we need the gradient of the radius. And for us to get the gradient of the radius, we must know the coordinates of the center. So if you know that you are going to find the coordinates of the center or even the radius, the coefficients of x squared and y squared must be 1, which is okay in this case. So we just sketch our circle and we say, assuming that is our point of tangency, which is given as 3 and 5, let me call it point A, or you can call it any other letter to make the work easy. Assuming the tangent is coming from point B, this is our tangent. We have the center here in the middle, and then this is the radius. Now, we need the coordinates of the center so that we can find the gradient of the radius. So you can go on and compare this to the expanded equation of the circle, compare coefficients, and then you get the coordinates of the center A and B. So here, the coordinates of the center are 1 and 4, just by examining the equation 1 and 4. Since we know the endpoints of the radius, we can find the gradient of the radius so that it can help us to find the equation of the tangent. So we say gradient of the radius. We do know that is a line. So we shall use the 2 points, that is the point of the center and the point of tangency on the circumference 3 and 5. Because radius is a line. If you have 2 points on the line, or the end points of the line, you can find the gradient of that line. Therefore, n is given by chaining y out of chaining x equals to x1, y1, namely points x2, y2. Or you can call these ones x1, y1, x2, y2. You shall get the same answers. So substituting here, y2 is 5 minus y1 is 4 out of x2 is 3 minus x1 is 1. That gives us a 1 out of 2. It gives us there 1 out of 2. That is the gradient of the radius. If I have not pressed the calculator, I normally have doubts. 5 minus 4 is 1. 3 minus 1 is 2. So that is the gradient of the radius. What do we know? We know that the radius is perpendicular to the tangent. But we know that the radius is perpendicular to the tangent. What is the implication of this? This implies that we know the product of the gradient of any 2 perpendicular lines is -1. So this means that if you have the gradient of the first line m1 and the gradient of the second line m2, as long as they are perpendicular lines, you get -1. So let me call this one my m1, that is my gradient of the radius. So if I substitute there, I will have m1, which is a half, m2 equal to -1. Therefore, If I make m2 the subject here, I'll get -2. I'll get -2. So -2 is the gradient of the tangent. Okay, that is the gradient of the tangent of the tangent. -2. Now, if you have the gradient of the tangent and one point on the tangent, you can find the equation of the tangent. So the equation of the tangent we have one point on the tangent, that is the point of tangency 3 and 5. And then we know the gradient of the tangent m2 as -2. The tangent is a line, therefore y equals mx plus c. This is my x, this is my y, that is my gradient m. Therefore 5 equals to m. M is -2 times x is 3 plus c, where c is the y-intercept. Now, let's make c the subject of the formula. C becomes 11. So we now write the equation of the line, which is a tangent. Y equals to, substitute only for m and c. M is -2, we leave x, and then plus c. C is 11. So this is the equation of the tangent to this circle at the point of tangency 3 and 5 using method 2. Now, in your examination, the question will always be open. So you can use the method that you want, or the one that works best for you, saving your time. So this is the solution to example 5. We have come to the end of finding the equation of the tangent.